Hey everybody, we're ready to start lesson 5 from chapter 1, angle relationships. Some very important relationships between these angles that we will carry with us all year. So this is a pretty important section, basically to get the vocabulary that we're talking about. Okay, first of all, we want to talk about adjacent angles. Adjacent means side by side, doesn't it? You've probably heard the word adjacent before. Adjacent, next to. But with adjacent angles, we have angles that must have a common vertex and they also must have a common side between them. So we would have something like angle 1 and angle 2. They're adjacent. They have a common vertex. They have a common side between them such that no points that are in the interior of angle 1 spill over into angle 2, and none of the interior points of angle 2 spill over into angle 1. You can have all sorts of adjacent angles. Angle 3 and angle 4 are adjacent. You can have adjacent angles like 5 and 6 when you've got the common vertex. You've got this common side between them, so they're adjacent, but look what's going on with their non-common sides. Their non-common sides form a straight line. Those have a specific name. These are called a linear pair. Now remember, pair always means two. So we don't have linear triples or quadruples or those types of things by definition or by vocabulary. We're going to have a pair of angles, so we're going to have two angles that have to be adjacent, two adjacent angles. So we know all the above things must be true, but we also see that their non-common sides form a straight line. You see the word line in linear? A linear pair, two angles, two adjacent angles with non-common sides forming a straight line. Okay? So that's two of the big vocabs we need to know. The next one is huge, huge, huge for us to remember. So I'm going to put it in purple because that's such an important Darlington color. We're going to make sure that we understand it. Vertical angles. Okay? Vertical angles are non-adjacent angles formed when two lines cross or when two lines intersect. Okay, so let's make crisscrossy lines. Vertical angles would be like angle 1 and angle 2. They are vertical angles. They are non-adjacent. They're not side by side, but they still have the same vertex. And see, the same line forms one side of one, and then another line forms the other side. So they're non-adjacent angles formed when two lines cross. And what is really helpful and important about these two angles that we'll get to later, but I'm going to go ahead and tip my hand now. Vertical angles are always equal. So if angle 1 here is 35 degrees, angle 2 is 35 degrees. Well, we just talked about a linear pair. Angle 2 and angle 3 up here are a linear pair. See how they go together to make a straight line? So if angle 2 plus angle 3 are a linear pair, they have to add up to 180. And if angle 2 is 35 of those degrees, we can easily find out what angle 3 is. It's going to be 180 minus 35. So I believe we're looking at about 145 degrees for angle 3. And if angle 3 is 145, then by vertical angles, this angle below is 145. Okay, so we have adjacent angles, and we can look at this in the book as well. And please look at this one. This is an example of angles that are not adjacent. But adjacent angles share a vertex. They have a common side separating them. Then if you have a pair of adjacent angles and their non-common sides form a straight line, that's called a linear pair, and they're going to always add up to 180 degrees because they make a straight line. Okay, adjacent angles don't always add up to a specific sum, but our linear pairs do. And our vertical angles or non-adjacent angles form when two lines cross. And our vertical angles are congruent to each other. All right, two other very important words or terms that I want to make sure that we are comfortable with are complementary angles and supplementary angles. Now this is the complementary with an E. Complementary angles are a special angle pair. So since it's an angle pair, that means we're talking about two angles. Complementary angles add up to 90 degrees. The measure of the first one plus the measure of the second one equals 90. A and B do not have to be equal to each other, but they can be. There are instances when they will be, but they don't have to be. They do not have to be adjacent, but they can be. I could have a 30-degree angle up in the science building, and on the history hall, I could have another angle over there that's 60 degrees, and they're still complementary. Any two angles that add up to 90 degrees are complementary, whether they are adjacent or not, whether they are vertical or not. Well, that would still be true. Okay. Then the second case scenario we have that we want to look at that's very important to us are the supplementary angles. It's my abbreviation for angles. And supplementary angles are still a pair, so we're talking about two angles here as well. This time our two angles are going to add up to 180 degrees. So our linear pairs are always supplementary. Because they are two angles that add up to 180, but they are adjacent. Okay, now supplementaries don't have to be adjacent, just like complementaries don't have to be adjacent. So they can be, but they don't have to be. Okay, so can be adjacent, both of them can be adjacent angles. Don't have to be adjacent angles. kind of sloppy. I'm sorry, but I just want to underscore that concept. All right, we're talking about lines coming together and intersecting. So we want to talk about a specific kind of line that intersects that I know you've talked about before. That didn't work out very nicely, did it? I think I can make that a little bit better. Oops. Let's see if I can make that a little bit better. Maybe not a whole lot, but that looks pretty sad. That's a little bit better. Okay. So we've got two lines here. I'm going to name them, like I told you I normally do, line 1 and line 2. And they are perpendicular, so I'm going to put my little 90-degree symbol in there. That tells me that those two are 90 degrees. Now let's think about what all we've talked about in the last few minutes. We know that if this first quadrant angle is 90 degrees, this angle has to be 90 degrees because those two are vertical angles, and vertical angles are always congruent. I also know that this first quadrant angle that I've just named 90 degrees and the adjacent angle right next to it that takes up the second quadrant, those two angles form a linear pair. And angles in a linear pair have to add up to 180, so this guy has to be 90 degrees. That makes these two a linear pair that are 180. And if my second quadrant 90 up there is vertical to this fourth quadrant 90, we see when I have parallel lines, they intersect and form 4 right angles. So we've got a lot of ideas about perpendicular lines that we can now conclude. Perpendicular lines intersect to form 4 right angles. Perpendicular lines intersect to form congruent adjacent angles. Think about that for a second. If they're all 90, then the one they're next to, they're always equal to because they're all 90s. Segments and rays can be perpendicular to lines or other line segments and rays. You don't have to have just lines to be perpendicular. The right angle symbol in the figure indicates that the lines are perpendicular. That's a very empowering symbol. This upside down T symbol means is perpendicular to. So in this drawing, we have line AD is perpendicular to line CB. Using the lowercase script notation on my drawing, I would say line L sub 1 is perpendicular to line L sub 2. When we put our lines on the coordinate plane and we graph lines and we want to determine whether or not they are perpendicular or not, to be exact, we need to find the slope of each of those lines. So what I'm trying to get you to remember from algebra is the relationship of the slopes of perpendicular lines. Okay? The relationship of the slopes of perpendicular lines. Perpendicular lines have slopes that are negative reciprocals of each other. So if line 1 has a slope equal to x, then line 2 must have a slope of negative 1 over x. They are negative. I don't know how I was going to spell negative with an R. Negative reciprocals. Or you can say opposite reciprocals. So when we show something is perpendicular on the graph board, we have to find the slopes of the line, and I hope you remember the formula for slope given two ordered pairs. Again, this was one of the formulas that I mentioned to you in lesson 1. Okay, remember the slope, which is m, is the difference of the y's over the difference of the x's. And I'm sure you've got that down pat by now. This chart is one that I want you to read and spend some time with, because I want you to be able to look at a drawing when we get to school and say, hey, we can't assume that. We can't assume certain things are true. We can assume some things, but there are some things that we can't assume are true. The biggest thing that I can suggest to you with regard to assuming if something's true or not is if you find yourself saying, the drawing looks that way. For instance, if you say, well, that must be 90 degrees because it looks that way, or those two must be equal because it looks that way. If you don't have any evidence to back up why you're saying something, you cannot rely on it looks that way. You just cannot. So if you find yourself saying that, step back and stop, because something's not right. All right, let's go up here to example 3 and see what they're doing up here. Find x and y so that PR and SQ are perpendicular. All right, let's darken those in a little bit so we know which lines we're talking about. PR is this guy, and SQ is this guy. So TW is a nice little visitor there, but he's really not helpful to me, or not one of the lines we're talking about. Okay. If these two lines are perpendicular, then we know we have a right angle, right? We know that we've got 90 degrees all the way around here. I'm making those a little bit big so that I don't mark over the notations they've given us. So I would know that to find y, look up here at PTQ. PTQ is 90. Because I've got perpendicular lines, so 4y minus 2 would equal to 90, and I could solve that as they do here. Now down here at angle STR, you see these two angles go together. So we've got a little angle addition going on. Add one of those little angles to the other, those two little adjacent angles, they make that 90-degree angle. So they've worked that out for us over here. Okay? All right, on this page, page 50, I want to look at number 4 and number 5 down here, a little algebra review. We're going to have a lot of algebra in our class. So let's look at what we've got. Let's read these word problems, which I love, word problems. Let's look at number 4, the measures of two complementary angles. Okay, the fact they're complementary tells us they add up to 90. So two complementary angles are 7x plus 17 and 3x minus 20. And they are complementary, so they add up to 90. We have to find the measures of the angles. So again, we're going to find x, and then we're going to plug that x in to find these missing angles. Let's see what we've got. Combining on both sides, 10x minus 3 equals 90. 10x is 93. X is 9.3. And then remember to solve this and answer the question. I have to go back and plug in the 9.3 to find these two measures. Once I find them, I'm going to want to add them together to make sure I get 90 degrees as a double check. Alrighty, let's set up the next one. I don't have my calculator with me, and I'm not going to take time to do the calculations when I know you can do them, or you wouldn't be in an honors class, right? So let's look at number 5. Lines X and Y intersect to form adjacent angles 2 and 3. I better draw this. I may not need it, but it sounds like something I might want to draw. So I've got lines X and Y intersect to form adjacent angles 2 and 3. If angle 2 here is 3A minus 27, and angle 3 is 2B plus 14, find the values of A and B so that X is perpendicular to Y. Well, if X is perpendicular to Y, then I would know that each of these would have to add together to give me a 90-degree angle. Okay, now over here I had to add them together, right? And over here I have to set each one equal to. Let's see, 9. And let's see, subtracting 14. And let's see, is that all we had to find? Find the value of A and B. So yeah, we're done on that one. Very good. Alright, I think we're in good shape here. I do want to look at 24 here and kind of give you a heads up on how to avoid an error that I see a lot of kids make. When you're looking for vertical angles in here, and I don't even know if we are on this one or not. Let me make it bigger. That's just too small. Whoops. When you want to know if vertical angles, or if two angles are vertical angles or not, I always like to come in here and zigzag my lines. For instance, if I kind of zigzag that line and zigzag that line, then I can see that these two angles are vertical. Now, I don't think I need that in that situation. I just wanted to use a figure that had more than two intersecting lines there to show you that sometimes you're going to have to, this line ain't going to want to go, is it? Sometimes, well, we'll just leave it alone. You've got to be careful to make sure that it's the same, it's two lines that are crossing that you're pulling vertical angles from. Let's look at, let's look at number 26, just for the fun of it, okay? The measure of an angle supplement is 76 less than the measure of the angle. Find the angle and its supplement. Sounds like a good old algebra problem, doesn't it? So I'm going to let x equal the measure of my angle. Okay, the measure of an angle supplement. Okay, now the supplement is 76 less than the angle. So x minus 76 is the measure of the supplement. Now, what do we know about an angle and its supplement? We know that if you add them together, you get 180 degrees. So 2x minus 76 is 180. 2x is 256. I hope I'm doing this arithmetic in my head correctly. X is 128. And so x minus 76 is the other angle, because it said find the measure of the angle and its supplement. So that's going to be 252. So those are my 2 degree measures. So these are both supplementary, so these are going to both be 180s. Okay, so by now, I think you're getting the gist of what kind of problems I like. I love these problems all through here. So if you want to spend some time looking at those and making sure you understand them, not so much the physics problem right now, even though it's really not difficult. I don't want you to get bogged down with that right now. I'm still too interested in getting you with the basics of geometry piece. So maybe we should just pick out a couple of these and see where we can go with them. Let's see. How about we just pick, I'm just going to pick 30. No particular reason why. I'm just picking it out because it's in this group of exercises and we can use our drawing over here. Let's see what's going on with old 30 over here. All right. If angle JNP is 3x minus 15, and JNL, now this is this whole thing right there, is 5x plus 59. Find the value of x so that JNP and JNL are supplements of each other. In other words, that they go together and make a straight line. So what they're telling us to do is add, whoops, that didn't go well, did it? Is to add these two, my 3x minus 15 plus my 5x plus 59, and that's going to equal 180 degrees. And I know you can do the algebra on that, so don't shy away from any of these problems. Shall we look at one below here? Let's look at 34 or 35, either one. I think I'm just going to pick 34 for this one. When you get your textbooks in the fall, the odds will be answers you can look up sometimes. So let's look at 34. Rays AB and BC are perpendicular. Okay, time to draw a drawing. So I've got A, B, and B, C. I could have gone down, I just didn't have any room. Okay, ray AB and ray BC are perpendicular. Point D lies in the interior of ABC, so I've got a point D out here floating around somewhere. The measure of ABD, so we're going to come right in there, that angle right in there is 3R plus 5. And then DBC, this angle in here, is 5R minus 27. So we're supposed to find the measure of each of those two angles. Well, since we've got these angles are perpendicular, I know I have right angles. So the two angles they've given me can be added together. 3R plus 5 plus 5R minus 27. They equal 90. And then, of course, I know you can go from there and solve the algebra out. Okay, so we've got a lot of heavy algebra, but the main thing here, vertical angles, adjacent angles, linear pair, vertical angles are congruent, complementaries and supplementaries. You might want to just work through some of these and check them. And then, of course, your homework is on the worksheets that you can work some problems and put your pencil to paper. Make sure that on your homework you're using a pencil. Make sure that you're showing your work because you want credit for your work. An answer that comes out of the blue you don't get credit for. Always put down your work. Never use a calculator to replace your work. The calculator is to help out your work, but you still need to write down what you're getting with your calculator. So make sure that you're making wise choices to do accurate, good mathematical practices. Looks like we have one more lesson to go. Again, please comment with any questions that I can help you with, and we'll see you for the next lesson. Bye-bye.